pages. There's my acronyms. Oh, I pointed out that I wanted to show the equivalences because notice we have to be given three things. And the only thing each one can be is either a side or an angle. So that's two things. So in each blank, there can be two things. So how many possible ways could I write out S or A in three blanks? Well, that would be 2 times 2 times 2, which is 2 cubed, which equals 8. Okay, so I wanted to make sure we hit every possibility. So 1, 2, 3, 4, which we said we're going to consider the same as this one, but it's still another way to write A's and S's in three blanks. 6, 7, 8. So there are no other possible ways to be given three parts of a triangle using just sides and angles. Okay, so let's look at specifically the law of sines. So once again, let me go back a second. If they give you three sides, obviously now this would have to be angle A because it's opposite little a. This would have to be angle C because it's opposite side C. And this would have to be angle B. So those are the three things you would have to solve for. Okay. So when they say solve the triangle, they're going to give you three parts, and then you have to find the remaining three parts. So in this case, you need to find angle A, side B, angle C. And again, you can tell which parts go where. Side A is opposite angle A. Side B is opposite angle B. Side C is opposite angle C. So if they use PQRS, doesn't matter. Okay, if they give you P, little r, and S, and they tell you it's triangle, PQ, whoops. Okay, I just said PQRS, which is four things, so I'm going to change it to PRS. So if they give you triangle PRS, and they give you angle P, side R, angle S, okay, well, it's easy to tell what goes where. R has to be the angle opposite side R. Side S has to be opposite angle S. And side P has to be opposite angle P. Okay, that is standard notation. Know it, use it, love it. Okay, now moving on. Let's look at our law of sines. In triangle ABC, with angles ABC, opposite sides, ABC respectively, again, that's just the standard notation. The following equation is true. Sine of A, angle A, over side A is equivalent to sine of angle B over side B equals sine of angle C over side C. Now, first thing you might be saying is, wait, that's upside down than what you showed us in the proof. That is true. I showed you A over sine A equals B over sine B equals side C over sine angle C. Okay, that's the one beauty of this law. You can write it either way. Doesn't matter, up to you. Personally, what I do, if I'm solving for an angle, I write it the first way. I put the angles on top, the sides and the bottom. If I'm solving for a side, I use this way. It just saves me a step. Okay, so up to you. Either way is fine. As long as you do your algebra correctly, it will work. Now, remember those acronyms. Okay, law of sines you basically use anytime you're given two angles and a side, or the special case, the bad word backwards, side angle. Okay, this is such a special case. It has its own name. It is called the ambiguous case. Let's see if I can type that nicely. Uh-oh. Oh, that looks pretty good. Didn't put in the word case. Trying to write neatly so it recognizes it. Okay, so there's the ambiguous case. So we will do that on the next video because that is such a special case it will take a while to explain. Okay, so today we're going to do an example of each of these. Angle, angle, side, angle, side, angle. Now, a lot of people might look at this and go, oh my God, I got to memorize when to use what. Well, I actually did this in this order for a reason. If you remember the first two, okay, side, 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 angle, side. Okay, you're going to use these for two things. One is law of cosines, which will be in a future video. Okay, and the second case is they both have special area formulas. Special area formulas. Okay, and we will learn those formulas when we do law of cosines. So if you just know those two cases, if it's not those two cases, then you're going to use law of sines. We have no other laws, no law of tangents, no law of cotangents. Okay, so I just know when to use for law of cosines. If it's not one of these two cases, then I know it has to be law of sines. Some people come up with other ways. Basically, anytime you're given two angles and a side, it has to be law of sines, except for the special case, okay, which is why I don't like that way. But you need to know when to use which formula. After you use them, sometimes it becomes obvious. And I'll point that out when we do our example.